Cool.
That works for me. So I've already started on the quiz.
Oh. All right. 1 second. Group meeting. I think this is it. How many questions are there?
20.
Oh dear.
Yeah.
And I forgot to open my book. I finally started watching a video. I watched the video yesterday, and they can be really helpful, I must admit.
Yeah.
I don't know why I haven't been watching them, but yeah, they can be helpful.
Yes, I know. Those videos are nice. I need to take the time to watch them.
Yeah.
So let me start from this nifty. Let's practice with understanding. The point estimate for P is P hat. Point estimate for P is P hat. Okay. All right. So you ready? You got the test up?
Yeah, I'm on number 3.
Okay, so if you plug in 52 females as X1 in the spreadsheet, and then 42 males as the X1 in the spreadsheet.
1 second, I'm trying to open one spreadsheet. That's categorical data analysis spreadsheet, right? Or HAP. Let me see. Might be this one. Okay. This is it. Two proportion. Okay. So P1, no way. X1 would be the number of female. Which one are you using? 2 sample Z test for proportions?
Let's see.
This one right here. Let me see if I can.
Yes, 2 proportions.
Okay. So then so X1 would be 18 and shoot. 1852, 1742, right?
Is there a question again?
Yeah, 1852, 1742. So I'm gonna show you how I'm doing it. This I'm trying to follow what the video did, but I'm not sure if I'm doing it right. So this thing is dumb sometimes. There we go. Can you see my screen?
Mm-hmm.
So here, so I use X1 for 18, N1 for 52, and then X2 for 17, and N2 for 42.
I think your numbers are a bit off.
Really?
I think you need to be using the your n needs to be the total. So
Oh,
for n you would use 70, and then for
okay.
n2 you would use 59.
Okay, so 70 and then 59.
And then I believe x is the number that can smell it. I believe.
X is the sample. Oh, that'll be P. Hmm. Okay.
So I think your x1 would be 52 and your x2 would be 42.
Wait, my X. I thought. So this is N, right?
I think so. Yeah, it should be in.
Okay, and are they asking for yes? Okay, so this will be my yes, and then this will be my well, actually,
We're doing two groups, female and male, so X
okay.
should be your yes
So
on the female, and then X2 would be your yes on the male.
X will be my yes in the middle. So I got that correct. And then my N1 will be 70 and my N2 is 59, right?
It should be X1 is 52 and X2 is 42.
Oh. X. Oh wait, then did I get this right then? Because okay, sorry. I think I'm giving you more headache than I'm helping. So X1 is 18, N1 is 17 or 52.
You think that our X1s are the number of female and males that cannot smell it? You think they're the no's?
Hmm. That's what let me see. Let P1 be the proportion of females in the population who can test PTC. So that's a yes. And let P2 be the proportion of males in the population who can test PTC. So I think both sides is a yes, yes.
Yeah, so X1 is 52, X2 is 42.
Okay. X1, 52, 52.
42.
Oh, sorry. I'm still waking up, can you tell? And then my N1 is just the total, the number of that grew, and then N2 is 59, right?
And then you need to change your type of test to P1 is not equal to P2.
Confidence interval is it still at 95?
Yep.
Okay.
At this point, it doesn't matter to answer question 3 and 4. We're inputting the result of the p hats. So
Okay.
the confidence interval doesn't affect the p hats.
Okay.
So number 3 is just p hat 1. Number 4 is p hat 2.
We should have put this appropriate, so equal to, not equal to. Oh, no, there's, wait. It's this one, right? Number 5 is the first option.
Yeah.
Create a 95% confidence interval for P1 minus. You to input your answer for the one estimate. Wait, it's already done here. I don't need to change anything.
Well, the problem is that's what I've been trying to figure out what the point estimate is. So
Oh, I,
I'm not really sure what that is.
so in the video, let me in the video they gave this lengthy formula that no, that's not it. It was something like this with
In lesson 17, it says.
so it was in lesson 18 part 1 video. That's I think that's the formula right there.
So in lesson 17, it
You see
says
it?
that p hat is called a point
I think it was
estimate
pretty
of
much
p.
confidence interval. Maybe.
So I believe that our point estimate is the p value.
Because that okay. Is oh,
You agree with that?
yeah. I think in the last homework we did, they asked for the first point estimate, which is the first p-value that you have. Or at least I selected that on the last quiz and I got a margin of error.
All right, the formula for the margin of error.
Margin of error.
Margin of error for this 95% confidence interval. Okay, so this, all right, we've got a formula here. Let me show you my screen.
Okay.
Okay, so you see the margin of error formula here.
Mm-hmm.
But what n are we referring to?
So we need margin of error for two proportion. So this is for one. We need it for two.
Okay, yeah, good point. But in lesson 18, it doesn't show the formula for margin of error.
Let me look in the index real quick. Index. Oh, they made it to the index I. Margin of error, margin of error. Nope, it's not even in the index.
Okay.
I think I'm just gonna Google it. So let me share my screen real quick. I saw a formula like this somewhere in a book, but haven't had it. So something like this, but not quite. I know it was like N1 plus N2, but I saw something like this I think in a video or in a book somewhere, but let's see if I can try to find it. Let's see.
All right. Two proportions. Measures contain constant.
It's funny, the entire book on 18 didn't even mention margin of error. There we go.
The value of the this thing. This is right here. This statistic. Get the value of the test statistic. distribution and p-value.
Yeah, didn't even mention a single thing about margin of error in the book. Probably might have done in the video.
All right. Dang it. Maybe we're overthinking this.
I'm like going through the video one slide at a time to see if I will see anything.
Margin of error, man, that's always been the problem.
Remember that one time you came up with that awesome formula?
Yeah.
Oh, let's see.
Yeah, it only worked that one time, though.
Right of the margin of error. Let's see here.
Okay, well, 0.3. There's 9. Okay, so I did that same thing that I did earlier where I just looked at the difference between the lower and upper bounds. So that's my best guess at this point. And so for 7, I have the answer at 0.309.
0.309, okay. Now, okay.
I mean, we've got to move on, so.
That's true. Lower bound. The lower bound is just what it is here, right?
Yeah. With A equals 0.05, what decision do you make? It's higher than.
Oh, our p-value
is greater than 0.5. We will fail to reject the null hypothesis.
Fail to reject it, so it's been a while since we failed to reject.
I know.
We should have followed statement that describe the outcome.
The following statements best describes the outcome of this study.
Second option.
There is sufficient evidence. Yeah.
Either second or third, but
there's sufficient.
One second. Let me look at the end of that video. It states how we can actually it is in part 2. Dang it. How can I get to part 2 of this thing?
Yeah, I think it's the second one. Okay.
Okay.
Number 12. Number 12 writes into the admission hard text stay with different data out of 118 519 hard text during weekday. Here. P1 is the proportion of patients who had a heart attack and were admitted on a weekday who died. And P2 would be the proportion of patients who had a heart attack and are admitted on a weekend who died.
Okay, so let me try from what we did on number one. So in this case, X1 would be 16713, and N1 would be 188519, right? Well,
What was that second number?
118,519.
Well, that would be our N. So yeah, 118,519 would be our N, and then X1 would be our. It's asking for who died. So 16713 would be our X.
Okay.
Our X1. That's what you said, right?
Yeah.
That's what I thought.
So 16713.
4244. So our X2 would be 6155, N2 would be 42447. So are the conditions for conducting a hypothesis test satisfied?
I'm still entering. Should be. I think we have a giant time for that. Yes, they're met. All the numbers are higher than 10. So.
We're also setting our type of test to less than.
Okay. So the conditions are met. Let's see.
The conditions for conducting a hypothesis test are satisfied. I believe so.
Which set of hypotheses is appropriate for addressing the research? Equal to and less than last option.
Yep, I agree. So number 14, use the data in the table to find P1.
P1. Yeah, one. So that's 1.141, right?
Yep. And P2 be 0.145. And the z-score minus 2.020.
Yep.
Given the z-score from the last question, which should you shade the left or the right of the z-score for the p-value? Well, we're doing less than, so it would be to the left.
It's a less than. It's a one tail test. So we'll shave one side, the left side. You're right.
Yep, because we're doing less than. What is the p-value for this test? 0.022, right? What's the p-value, number 18?
Wait, what did you get?
0.022.
That's the z-score. P-value is
No, it's the p-value.
nice. 1 second. Oh, dang it. Less than. Oh boy. I have mine to greater than instead of less than.
Yeah.
Cool. So the p-value is less, we reject.
Yep. So we reject the null hypothesis, and that means that there is insufficient evidence. It's either the first or second.
You mean first? Oh yeah. The proportion of patients who have a heart attack and are admitted to the hospital on a weekday who dies less than. And it should be higher than, right?
I think it's the second one.
Okay. My teacher's in class now, so I gotta go.
All right. Good luck, man.
I really appreciate it, Justin. Thank you.
Hey, we got an 80%. All right. See you later.
Awesome. See ya.